we could encounter asbestos-containing building materials. This could occur in any building where we live or work, and could potentially result in asbestos exposure if we're not careful about what we do and how we do it. Inhaled asbestos fibers can cause life-threatening diseases, especially when inhaled in large quantities.
But this need not happen. The mere presence of properly contained asbestos does not present a health hazard. We can readily protect ourselves against asbestos hazards. The key to our individual safety rests in awareness, knowledge of what asbestos is, where it is likely to be located, and how it becomes dangerous. Hello, I'm Lisa Williamson. Asbestos has contributed to the early deaths of thousands of people, perhaps tens of thousands. We will never know their number, because people have used asbestos for over 2,000 years. Asbestos is no longer an unknown menace. It is not a plague that kills mysteriously. We know how asbestos fibers attack the body. We know when asbestos is hazardous and when it is not. It is hazardous only when asbestos fibers are released into the air and inhaled. We can see the larger, heavier fibers that sometimes form a sort of dust when asbestos is disturbed, but we cannot see the dangerous small fibers that can break loose and float free from exposed asbestos. These fibers are utterly invisible to the naked eye, so light they can remain suspended in the air for long periods and move on the slightest currents. Many building owners and managers have asbestos management plans to help them identify and properly maintain their asbestos-containing building materials so that fibers are not released into the air. We have a responsibility to avoid working in areas where asbestos fibers might have been released. We must also ensure that our work does not cause damage to intact, known or suspected asbestos-containing materials. Such damage could potentially cause a release of asbestos fibers. With all we know about asbestos, and we know a great deal, the one thing medical science has not been able to determine with certainty is how much exposure to airborne asbestos fibers does it take to endanger our health. In the absence of absolute figures, government regulators established rigid standards for the maximum level of asbestos fibers that may exist in our air. Regulators have also established strict procedures for working with and around asbestos. We don't work with asbestos at all. We work around it only when it's safe to do so. Our safety begins with awareness. This video aims to help you build awareness. It's all pretty logical. If we understand what asbestos is, how it behaves, what its properties are, we'll understand how and why it's been used in this country. As we grow to understand how it's been used, we'll know better what products and materials might logically contain asbestos, what to watch for, and where to look. This video will identify the most common asbestos-containing materials and products. This knowledge, combined with an understanding of how asbestos fibers break free and become airborne, will go a long way toward helping you avoid exposure. We'll also detail specific potential health hazards related to asbestos. We'll spell out the regulations and company policies designed to keep you safe. Asbestos is a naturally occurring mineral. It takes form in certain varieties of serpentine rock. Serpentine is the state rock of California. Like most of Earth's minerals, asbestos is composed primarily of silicon, water, and magnesium. Unlike other minerals, the kind of asbestos with which we are concerned contains molecules which align themselves in very long, thin, hollow fibers that are flexible and, by weight, stronger than steel. There are several kinds of asbestos. The samples shown here have been highly magnified under a powerful microscope. Chrysotile asbestos is far and away the most common asbestos to have been used in the United States. 95% of the asbestos found in American buildings is chrysotile. Chrysotile typically appears white in color.
Asbestos has been extracted in volume from underground and open-pit mines since the late 1800s. At the peak of its popularity, asbestos use in the United States reached 1 million tons per year. Many buildings, particularly those constructed before the 1980s, contain asbestos in some building materials, even though, in work that began several years ago all over the country, asbestos is being removed from buildings. Asbestos removal is done by workers who receive special training and medical examinations as required by OSHA and the EPA. They wear protective clothing and respiratory protection, frequently doing their jobs in sealed, posted, and regulated containment areas. We never enter these asbestos containment areas, not ever, no matter what. If asbestos removal or containment is being done in an area where you had planned to work, stop. Don't enter. Call your supervisor.
Bob, it's Chris. I'm over at 19th Avenue at that ODOT-1 we were talking about. And it appears we have an asbestos problem over here. I can see the terminal through a small window that with a plastic overlay. And there's people in there working with respirators. So it looks like we'll have to no access this one. Exactly. If asbestos is so dangerous, why is there so much of it around?
Good question. The basic answer is the useful applications for asbestos were known long before its harmful effects became generally known. The word asbestos was derived from the Greek adjective meaning inextinguishable. During the time of ancient Greece, its fibers were woven to form lamp wicks. Asbestos does not burn, but its hollow fibers held lamp oil very nicely, making them excellent, long-lasting wick material. These same fibers were easily woven into fabrics. The Egyptians used them in cremation and other burial shrouds. The Romans also wove asbestos into fabrics, such as napkins, which they cleaned by holding them over flames. Asbestos use in Europe diminished after the fall of the Roman Empire. Then came the steam-powered Industrial Revolution with its boilers, pipes, turbines, ovens, and kilns, all of them heat-producing. Industry needed something to handle the heat. Asbestos, the new miracle mineral. In time, asbestos was woven into common fabrics. It was particularly useful in firefighter suits. Even their respirators contained asbestos. Many workers wore heat-insulating gloves. After December 7th, 1941, the volume of asbestos would take another sudden leap in American industry.
The outbreak of World War II created a dramatic increase in shipbuilding, and with it a huge demand for insulation products. Thousands of ships and submarines were launched in record-breaking time. Every one of them contained large amounts of asbestos. Great numbers of men and women worked utterly unprotected with and around uncontained asbestos in war plants. Many were exposed to very high levels. The fibers they inhaled would shorten the lives of many, but their lung diseases would not develop for many years.
After 1945, the asbestos industry shifted gears to join the post-war construction boom. The properties of asbestos seem to make this mineral an excellent additive to building materials, like exterior siding. All of these post-war houses are sheathed in asbestos. In fact, during that time, asbestos was used in most building construction, employed in 2,000 to 3,000 different products and applications. It was wrapped around boilers, heaters, and pipes as thermal insulation. Asbestos was also found to be a good acoustical insulation and was used as such in ceiling tile. It was sprayed and troweled on walls as well as ceilings, sometimes as a simple decorative surface. It was sprayed on steel beams as a fireproofing agent and was mixed into concrete and cement. It was incorporated into flooring materials such as tiles and mixed with the mastic that holds them in place. Gaskets and packaging materials contained asbestos. Its insulating and fire-resistant properties led to its inclusion in roofing, felt, papers, and shingles. Asbestos does not readily conduct electricity, so it was employed in electrical insulation. Then, as the asbestos boom raced forward, other developments began to emerge.
It started in the late 50s and early 60s. Many asbestos miners, factory workers, shipbuilders, sailors, and others who had typically worked directly with asbestos and had been exposed to high levels during World War II began to show signs of asbestos diseases, cancer, and something that would come to be known as asbestosis.
Government regulators were not far behind those manufacturers and builders who volunteered to stop using asbestos in certain applications. Agencies gradually began to ban friable asbestos during the 70s. A friable material is one that can be crumbled, pulverized, or otherwise caused to release dust by applying simple hand pressure. If this friable material were asbestos, it's not, I assure you, it just looks like asbestos. But if it were, it would be releasing invisible fibers for me to inhale as I crumble it. Remember, too, that the most dangerous asbestos fibers are the tiny ones we can't see. Let's spend some time on the medical aspects of asbestos, the health hazards. Dr. Gary Fujimoto joins us from his medical office in Burlingame, California. Welcome, Doctor.
Thank you for inviting me.
Dr. Fujimoto is medical director of the occupational medicine departments for both the Palo Alto Medical Foundation and Mills Peninsula Hospital. During his medical training, Dr. Fujimoto conducted research on asbestos-related diseases with renowned asbestos researcher Dr. Irving Selikoff. Tell us about your background in the field of asbestos.
Currently, I work with a variety of different people who are exposed to asbestos who get referred to me, since my specialty is with toxic chemical and biological hazards. Much of my work also involves teaching medical students at Stanford about many of the chemical-related hazards that are out there.
We know that asbestos is an inhalation hazard, but how does it affect the respiratory system?
Asbestos is a very interesting and unique compound where you get very fine fibers, in this case of rock. Those fibers are so fine that they could be woven and are very strong and durable. And it is also because of the extremely small nature of these fibers that they can be inhaled into the lungs, where they can reside and lodge for many years. The body tries to engulf these fibers through the scavenger system in our lungs, which is called the macrophage. The macrophage, however, can't break down rock fiber, and as a result, we believe that many of the problems and health problems that come from inhaling these fibers are due to the fact that instead of being able to gobble up these fibers, enzymes are released, which can in turn cause secondary medical problems.
What are the possible health effects of asbestos exposure?
Asbestos actually can lead to a variety of different problems. And lung cancer is far and away the most significant problem that we're currently seeing among people who have had inhalation exposures many years ago. And this can include various types of lung cancers, as well as a very rare form of lung cancer called mesothelioma. This is a cancer of the lining of usually the lung, but it can also be of the abdominal system. It's one of the few cancers that has been directly linked to asbestos fibers. I should also point out that there are other diseases that are associated with high levels of asbestos exposure, and that's called asbestosis. Asbestosis is a disease which is a fibrotic change. In other words, basically a shrunken lung which can't expand because different fibrous areas have developed within the lung itself. This is a disease that's usually found among people with very high levels of exposure over long periods of time, and is something that we're seeing much less these days. In fact, many of the people who I saw with asbestosis were people who were either working with this in the military and in shipbuilding, or plumbers, pipe fitters, steam fitters who had been working in the trades for many years during a time when there was no understanding that this really was such a dangerous material to handle, and where the levels of exposure were exceedingly high.
How much asbestos exposure is hazardous?
That's a very difficult question to answer. We do know that asbestos is a material that is found throughout our environment, and in fact, based on studies that have been done, every person who's lived in a major city in the United States has asbestos in his or her lungs. So we do know the levels of exposed individuals are extremely high, and yet we don't see the types of diseases that we have found in asbestos workers present in many of the city's populations. So that seems to suggest that people with very low levels of exposure are not going to have significant problems.
How long does it take before the symptoms of these diseases become apparent?
Asbestos-related diseases often are diseases which have a long latent period of time. And by long, we usually look at 10 to 40 years as being the range where from the time that somebody is exposed to the actual development of disease.
Can you tell us about the relationship between cigarette smoking and asbestos exposure?
The association between smoking and asbestos is extremely dramatic and important. And so many of our attempts when we work with those people who have had high levels of exposure to asbestos in the past, if they are smokers, is to work avidly to get them to stop smoking. The estimates range dramatically. Some studies have shown that as many as 90 times the rate of cancer is found among people who both smoke cigarettes and have a significant exposure to asbestos.
Does it matter if you're exposed one time for a long period of time or on several occasions? And what are the consequences of this exposure?
I think that the question of single exposure versus multiple exposure, assuming that these are relatively low levels of exposure, are often very difficult to address in terms of specific medical problems. We do know that many of the cases where we've looked at asbestos-related diseases were people who were working with this material every day with extremely high levels of exposure, where they were digging through the material on a daily basis or applying it on a daily basis.
Is there a test or exam that can tell if I've been exposed to asbestos?
There's no simple test to detect asbestos in the body. We can detect the diseases that are related to asbestos. For people who have had heavy exposures to asbestos in the past, we can see pleural plaques lining the lung, and that can be a marker that somebody has had asbestos exposure in the past. But the standard X-ray, and we have screened thousands of people who are plumbers, pipe fitters, and steam fitters who have had significant exposures to asbestos, the vast majority of these people have absolutely negative chest X-rays.
Thank you, Doctor. These documented health hazards have prompted extensive asbestos regulation at federal and state levels.
Federal and state asbestos regulations cover all private employers and their employees in situations where work activities could result in asbestos exposure. These activities include the construction, maintenance, or repair of structures containing asbestos construction materials. Other covered activities include housekeeping operations involving asbestos construction materials, as well as removal or encapsulation of asbestos-containing materials. The storage, transportation, and disposal of these materials is also regulated. OSHA develops and enforces regulations regarding employee training and exposure assessments, medical surveillance, personal protective equipment and respirators, as well as work practices and engineering controls. OSHA also sets the permissible exposure limit, or PEL, for workers. This exposure limit is based upon an 8-hour time-weighted average. The 8-hour PEL for asbestos is 0.1, or 1/10 of 1 fiber per cubic centimeter of air. For briefer periods of exposure, OSHA has established an excursion limit of 1 fiber per cubic centimeter of air averaged over a sampling period of 30 minutes. There are 2 applicable federal OSHA asbestos-related regulations. The first applies to general industry. The second applies to the construction industry. There are usually state asbestos regulations that also apply to various asbestos-related activities. The EPA, or the Environmental Protection Agency, is also concerned with asbestos. The EPA develops regulations and guidelines pertaining to building owners. These regulations cover building renovation and demolition, including disposal of asbestos waste. EPA defines acceptable methods for managing asbestos in place within buildings. When asbestos is to be removed, the agency defines acceptable removal processes, containment methods employed, and clearance testing. EPA and OSHA asbestos worker training requirements have been incorporated into OSHA regulations.
So, bearing in mind that asbestos is only dangerous when its fibers are released into the air, how do we limit our exposure to airborne asbestos? We've learned a bit about asbestos history, how it's been used. We understand its useful properties. It's fireproof, insulates against heat and cold, resists many chemicals, doesn't readily conduct electricity. It can be woven into fabrics. It's a good bonding agent for holding other materials together. We've learned the basics of asbestos regulation and when it became a regulated material. so we're already better equipped to recognize and avoid potential exposure. For instance, let's say a certain job involves working in the basement or utility room of a building constructed before 1980. We notice a furnace or boiler there. It's covered with an insulating material. So are the pipes connected to it. We'd have a pretty strong suspicion that the insulating material contains asbestos. We would know not to disturb it. And if that material is decayed or already damaged in some way, discharging friable asbestos, we wouldn't work in the area till the problem had been corrected. Unfortunately, the presence of asbestos is not always as obvious as it might be in the case of a big insulated boiler sitting in plain view in a pre-80s building. Example: 2 ceilings, both covered with sprayed-on acoustical or decorative material. One contains asbestos, one does not. Can you tell which is which? Don't feel bad. No one, not even the experts, can tell for sure without conducting microscopic analyses of the material. The point is this: we can work around intact asbestos without health risk, but we have to be sure our work does not disturb asbestos in a way that would cause fibers to be released into the air. For example, we wouldn't even want to touch an asbestos-containing surface like this acoustical ceiling or sprayed-on fireproofing. Both are too friable. A touch could release fibers. Other surfaces might not be quite so vulnerable, but we still have to be sure they do not contain asbestos before we disturb them.
This person is observing what appears to be asbestos-containing pipe insulation in an engine room. Could that be asbestos under the protective covering? What about the other pipes in the room? All could contain asbestos. This would be a good one to check with the building manager.
We must not drill, saw, sand, drive nails into, or otherwise disrupt asbestos-containing materials.
Even the best maintained asbestos pipe rack, for instance, could release fibers into the air if punctured. So when a job looks like it could bring you into contact with some substance you think might be asbestos, don't guess. If you're working in or around a commercial, institutional, or industrial building, find the building manager or person in charge of the asbestos management plan and asbestos survey reports.
Now let's broaden our knowledge about asbestos products and applications that aren't as obvious as the big boiler in the basement.
There are several different asbestos-containing materials in the building illustrated here. Virtually all are safe to work around unless they are damaged or have decayed in a way that releases asbestos fibers. Some are much more easily compromised than others.
Right. So the Environmental Protection Agency, the EPA, breaks down asbestos-containing materials into 3 categories according to their relative friability. Materials that most easily release fibers into the air are called usually friable. The other 2 categories are sometimes friable and rarely friable. There are 2 common materials in the usually friable category that are particularly friable. Just touching them can cause asbestos fibers to become airborne.
Sprayed-on fireproofing is often found in steel-framed buildings like the one illustrated here. Steel beams can bend or lose their strength under the high heat of a building fire, so steel frames were routinely sprayed with insulating asbestos, as were certain other surfaces like this parking garage ceiling. Sprayed-on asbestos fireproofing is no longer applied, as its manufacture was banned in 1973. But it was applied by some builders until large inventories of sprayed-on materials were used up at a later time. There is still a lot of it around in pre-1980s buildings. Regulations require that when such buildings are remodeled or demolished, this material must first be removed by approved asbestos removal contractors. This material may be encountered above suspended ceiling tiles. Since it's so friable, employees are not allowed to work in areas where they, their tools, or equipment might come into physical contact with sprayed-on asbestos fireproofing, unless they have more extensive training. If you must enter a ceiling plenum or area above suspended ceiling tiles, you should make sure that you will not encounter asbestos-containing materials. Place a ladder underneath the ceiling tile to be lifted. Gently lift one edge of the ceiling tile while leaving the opposite edge, the one that is parallel to the edge you are raising, in the grid. If any resistance is felt, or if the tile is obstructed by wires, ducts, conduit, etc., select another tile. Lift the tile edge several inches, gently and slowly, just enough to see if any suspect asbestos-containing material is present in the ceiling cavity. It will be necessary to shine a flashlight into the ceiling cavity to make this determination. Check all visible surfaces for evidence of sprayed or troweled-on material. Check the lower surfaces for fallen debris. Repeat this procedure for each side of the tile. If suspect asbestos-containing material is seen, gently lower the ceiling tile back into the ceiling grid. Contact your supervisor and inform them of the potential presence of asbestos. You must either confirm that no asbestos is present in the material, find a way to perform the work in an area where there is no suspect material visible, or have the work performed by a licensed abatement contractor. If no suspect asbestos-containing material is seen, lift the whole tile slightly above the grid and slowly move the tile over to one side and place it on the back side of another tile. Raise your head into the ceiling cavity. If there is still no evidence of asbestos-containing material, proceed with work. If suspect asbestos-containing material is seen, gently lift the tile up from where it was placed and lower it back into the grid in its original orientation. Contact your supervisor and inform them of the potential presence of asbestos. If this activity results in the disturbance of the actual ceiling tile, check with the building owner and make sure the tile itself does not contain asbestos. In addition to being sprayed on ceilings, acoustical material was occasionally sprayed on walls. As we've learned, not all such materials contained asbestos, but it's very difficult to distinguish between the materials that do and those that don't. Even the experts take samples for microscopic examination before declaring material to be asbestos-free. When the material shows water or impact damage, it is especially friable. Unless you know for sure, you should assume that sprayed-on material found in a pre-1980s building contains asbestos.
Let's look at asbestos-containing materials the EPA places in the sometimes friable category. Some of the more common products in this group are pipe insulation, boiler insulation, duct wrap, roofing felt, and ceiling tile. There are many others, of course, but these are frequently encountered.
Pre-80s boilers and commercial water heaters are frequently covered with asbestos-containing insulation. Very often, the piping connected to hot and chilled water systems was also asbestos-insulated. The insulation is usually encapsulated in painted or wrapped materials to seal it in place. The asbestos contained within becomes hazardous only when these sealers deteriorate or are punctured, torn, or otherwise damaged. Insulated piping may run throughout certain buildings. If the surface wrappings on the boilers or pipes appear to be cloth, this fabric itself might contain asbestos and should not be touched or otherwise disturbed.
So the thing to look for is evidence of damage or deterioration. It's pretty easy to spot. In this case, someone has improperly cut through asbestos pipe lagging, perhaps to replace a faulty valve or pipe section. This previously contained asbestos has now been made friable. Here, the wrapping is given way, probably because a water leak saturated the asbestos and made it too heavy for its wrap to contain. This illustration shows evidence of accidental damage. Insulated boilers, heaters, and piping may be located in unfinished basements or crawl spaces which have dirt floors. Asbestos released into this environment can mix with the dirt and become friable when dust is disturbed by someone moving through. If you see something like this, leave the area. Again, we don't work around loose, exposed, friable asbestos.
Commercial and residential forced air heating and air conditioning units are located in basements, mechanical and utility rooms, and in the case of air conditioning, occasionally on rooftops. In pre-1980s buildings, flex joints and seams on blowers and air ducts were frequently wound with asbestos-containing tape. Asbestos-insulated air ducts may run throughout these older buildings. They are frequently located above suspended ceilings. Technicians should be careful not to disturb the asbestos-containing insulation on these ducts. Asbestos-insulated ducts and pipes may also run through telephone terminal rooms.
Here's a sort of heads-up clue to the potential presence of friable asbestos. If you notice white or gray dust or clumps of crumbled gray material on the floor or other surface in a place where you plan to work, look around and above that deposit to see if there's anything that looks like an asbestos-containing material that might have discharged the dust and/or crumbled substance. If in doubt, leave the area and contact the building owner or manager. Ask that they show you the section of their asbestos survey report that addresses this area. If you're unable to find out about the material, consider your alternatives. Is there another route or location that can be used to avoid this questionable area? Often there is. When needed, contact your supervisor to discuss alternatives. It may be appropriate to request that the building owner or manager properly clean up the area first before the job can proceed. In no case should you touch or disturb dust or crumbled substances that might contain asbestos. Don't wipe, sweep, or vacuum it. Remember, harmful asbestos fibers are tiny. They'll pass right through the collection bag in an ordinary vacuum cleaner. Asbestos workers use special wet vacuums to pick up loose asbestos. We walk away from it and notify the building manager.
Some asphalt roofing material and roofing felt, especially in older buildings, contain asbestos. Silver painted on roofing emulsion usually does.
Let's move on to some of the common asbestos-containing materials the EPA classifies as rarely friable. These include vinyl asbestos floor tile, vinyl linoleum felt backing, the adhesive or mastic used to secure these floor coverings in place, gaskets, similar in appearance to this one. Incidentally, this is a new non-asbestos gasket, but which of us would know that by looking at it? The rarely friable list also includes asbestos-containing concrete, cement, exterior siding, and roofing shingles. We've covered a lot of information. We know how and why asbestos has been used. We know how it can affect our health and how it is regulated. We know when it is dangerous and when it is not. We've identified numerous asbestos-containing materials, certainly not all of the hundreds that exist, but those that you might be most likely to encounter. We know what to watch for and where to look. We know who to contact to find out about the presence and condition of asbestos-containing building materials. We know we don't enter regulated asbestos containment areas. We don't work around exposed, damaged asbestos material, nor do we touch or disturb any asbestos-containing material in a way that could cause the release of fibers. We also know what alternatives, such as rerouting, to explore that allow us to work safely while providing service to our customers. We have the knowledge, the asbestos awareness to avoid exposures. Thanks for watching. Take care of yourself.